Hello there, integrated science students, and welcome to our homework instructional video over plate tectonics. Welcome to the beginning of Unit 2, everything that is Earth's internal processes. So we're going to study certain phenomenon that occur that help to change our Earth, stuff that's happening inside of Earth that's constantly assisting in the ever-changing landscape that is our geology here on the face of planet Earth. The first one of those processes that we're going to talk about is plate tectonics, or the Plate Tectonics Theory. So we're going to break this video down into 4 topic areas here. Before we get into the actual theory, we're going to cover the history and some early evidence of plate tectonics and the movement of these gigantic slabs of rock. Then we're going to discuss seafloor spreading, eventually getting into the actual theory of plate tectonics and the boundaries that we know exist. And finally, the motion of the plates, so how these bad boys move around. Okay? First off, though, before there was plate tectonics, there was continental drift. A scientist by the name of Alfred Wegener was observing some natural phenomenon and said, you know what? I bet at one point in time all these continents on this planet were the same continent. One gigantic supercontinent. Pangea. He had a little evidence, though, here to support this idea, and back then, at his time, this was crazy. Okay, this was absolute crazy man talk. But what he did was he noticed that the coastlines fit nicely next to each other, like South America and Africa. So one piece of evidence that he provided was how these coastlines looked very similar to one another, like they fit together like a jigsaw puzzle. Another piece of evidence he provided were similar rock specimens, identical rock specimens, at different parts of the world, separated by gigantic bodies of water, coming from the same geologic formation or the same geologic feature. So rock existing in South America with the same identical chemical composition and evidence of climate at that time that rock was formed, and it being the same rock that existed in Africa. Okay, so he was noticing similarities between rock and mineral specimens on different continents that appeared to come from the same geologic feature, like a mountain, a valley, okay, a delta. All right. The last one that he recognized was species of animals. So not only geologic features, but he was recognizing how there was fossils of this land-dwelling animal in this continent as there was in this continent. Same thing with plants. There was also fossil evidence of one type of plant here and one type of plant here. So not only did that plant somehow travel over gigantic bodies of water, it didn't, remember, continents drifted apart, okay, but it was also existing in completely different climates. So some interesting pieces of evidence there that old Wegener came out with. And he called it the theory of continental drift, that the continents were once one gigantic supercontinent and they had drifted apart over time. He didn't get into them plates. He didn't talk about plates. He basically said somehow there was some feature, some process that was drawing the continents away from one another. And that was the major criticism that he faced. A lot of other scientists were like, okay, great, you've got this evidence that said this could happen, but what was the mechanism? What caused the change? After World War II, a gentleman by the name of Hess was using sonar, so sound waves essentially, to map the bottom of ocean floors. Okay? So he was shooting these sonar waves down at the ocean, and he was collecting the information based upon the distances that it had to travel and how quickly it would return. And he was creating a 3-dimensional map of the seafloor. He noticed that there was a special situation occurring in the Atlantic Ocean, that there was this gigantic ridge that was forming, a mid-ocean ridge system. And over time, they were able to document how there was some separation. It was one of our very first clues to plates existing on this planet, and that they were indeed interacting, and it was the first clue towards the actual mechanism or process that would help explain Wegener's continental drift theory. So not only did we have this sonar evidence of seafloor spreading essentially by mapping out the seafloor and seeing how over time these peaks were kind of pulling apart from each other and that there was this new rift valley forming in between the peaks. But we also were able to take some rock evidence from down at these mid-ocean ridges and recognize that age-wise they were a lot younger towards the center and a lot older towards the outside. And not only that, but the polarity, the magnetic polarity, also lined up with how we had understood how the polarity of our planet changed over time, the magnetic polarity of our planet. So little minerals were lining up in different angles, different directions, at different distances away from the center of this rift valley. So seafloor spreading was something that was documented by Harry Hess and gave further insight to how maybe Alfie Wegener was on to something with this continental drift theory. After an analysis of Hess's information, scientists finally started to sit down and think, you know what, I think we've got enough stuff here that we can develop the plate tectonics theory. Plate tectonics theory basically states that the crust of our planet is breaking up into several gigantic slabs of rock, kilometers in depth and enormous in area. These gigantic slabs are interacting with each other at all times and can be interacting with other plates in different fashions at different areas of the same plate boundary. There are three major plate boundaries that we talk about when we're talking about plate tectonics: convergent boundaries, divergent boundaries, and transform boundaries. Convergent boundaries are locations where two plates are slamming into one another. There are two types of plates: continental plates and oceanic plates. Continental tend to be very, very big and very, very buoyant. They're not very dense. Whereas oceanic plates tend to be very, very thin and very, very dense, really, really heavy. And that's all based upon the different magma that has been, or that is responsible for forming those plates. So when we have a convergent plate boundary, if they're two continental plates, essentially what's going to happen is they're going to ripple and we're going to create a mountain range. If it's an oceanic and an oceanic plate converging on one another, super, super rare though, okay, we could get somewhat of a small mountain range, or one would subduct under the other and go under. We see subduction as well when we have a continental plate and an oceanic plate. So here's my big, tall, thick plate. Here's my oceanic plate. Slam together. The oceanic plate, which is more dense, is going to subduct and go underneath the continental plate. Okay? Creating a few other geologic features here, such as a deep sea trench. And typically, this thing getting melted right here, this oceanic plate, coming up through the continental plate and giving us a lot of volcanic activity. Divergent plate boundaries are simply when the two plates next to each other are spreading apart. So you see divergent plate boundaries forming mid-ocean ridges and rift valleys on land. It can also happen between two continental plates as well. The last one are transform plate boundaries, where the two plates, whether it be oceanic, 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 continental, 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 are just sliding horizontally next to one another. Lots of earthquake activity reside around transform plate boundaries. How do these plates move? What's causing them to interact with each other at the boundaries? The simple idea of convection. Three major ways of transfer of thermal energy: heat, conduction, convection, and radiation. Radiation is the electromagnetic wave that transfers heat or other forms of energy. Conduction is direct heat transfer. So if you put your hand on top of a plate burner and all of a sudden you feel the heat, that's because the heat's getting directly transferred from that source to your hand. Convection would be like a convection oven, where you have a heat source heating up a fluid inside of an area, and then that fluid heats the item or the object. So the heat source is heating up the air inside of the oven, and then the air is actually cooking and heating the item inside of the oven. Convection is how our plates move as well. The core of our Earth is our heating element. The fluid is the mantle between the core and the crust. So the mantle is the fluid. It gets heated up, that liquid magma rises, and as it rises, it cools, and as it cools, it kind of glides and rubs along the bottom side of the crust. So you've got these convection currents that exist inside of the mantle of the Earth, cooling and heating and cooling and heating, cooling and heating. And that cooling and heating causes enough motion underneath the crust to make the crust move. Convection isn't the only culprit, though, to cause these plates to move. We've also got items such as slab pull, friction, and ridge push. Slab pull is kind of defined by like the covers on the end of your bed. Once those covers start to kind of pull off due to gravity, it's just a matter of time before you wake up in the middle of the night and they're completely off the bottom of your bed. You didn't kick them off. Gravity just slowly did work on the blanket or the covers and pulled them off of your bed, and you wake up cold. Ridge push we see with mid-oceanic ridges, and how gravity takes those ridges and pushes them apart because the ridges are higher than the surrounding sea floor. And friction is what's happening kind of with the convection. That fluid cools. When stuff cools, it increases the level of friction, okay? And that fluid then kind of can catch that plate and move that plate ever so slightly. So, the 4 topics we covered in this video: continental drift and all of Wegener's information to support it, all of his evidence, those 3 pieces, okay? We also talked about seafloor spreading and how it was what happened there kind of in the mid-1900s to get scientists looking back at Wegener's thoughts and taking current and new information to expand upon it, and eventually getting us to the plate tectonics theory, which was our 3rd topic. And then we talked about the boundaries that exist with plate tectonics and how those plates actually move. That was our 4th topic in this video. Hit me up with any questions. Adios.